In this video, we're going to cover the number of multiples in an interval, and we're going to solve these particular problems right here. And so let's begin. So in this example, I'm going to show all the steps. How many multiple of 3 are in this interval from 6 to 15? So we start with 6, and 6 is a multiple of 3. And then we just go ahead and add 3. So 9, 12, and 15. So the answer is going to be 4. Now, obviously, if it was a bigger number, this would be a much harder problem. And so there's a nice formula. So we do the last number, but the last number has to be a multiple of 3, minus the first number. Again, it has to be a multiple of 3, divided by our multiple, so 3, plus 1. And in this example, both 15 and 6 are multiples of 3. And so we can do 15 minus 6 divided by 3 plus 1. And 15 minus 6 is 9. 9 divided by 3 plus 1. And 9 divided by 3 is 3. 3 plus 1 is 4. And so we also get 4 this way. Now this is the next problem. So 34 is not a multiple of 3. And the next number, 35, is also not a multiple of 3. But 36 is. So our starting number is 36. And 45 is a multiple of 3. So 36 to 45. Here, because it's so small, I'm also going to show it both ways. So we would be 36, 39, 42, and 45. And so we're going to get 4 numbers. So how many multiples of 3 are in this interval? 4. But we're also going to use the formula. And the formula is more important because that's ultimately how you're going to solve all types of problems. So 45 minus 36 divided by 3, because our multiple is 3, plus 1. 45 minus 36 is 9. 9 divided by 3 plus 1. 9 divided by 3 is 3. 3 plus 1 is equal to 4. And so it's a match. Now, another example, 4 to 505. So 4 is obviously a multiple of 4. 505 is not. And at the same time, we don't know what the next number would be. So what I would do for this example is do this. 505 divided by 4. If I use a calculator, I get 126.25. And so my last number, what we're going to do is we take 126. 126 times 4 is going to give me 504. And so we're going to say from 4 to 504. Use a nice formula, so 504 minus 4 divided by, in our case, 4. So 4 plus 1. So 504 minus 4 is 500 divided by 4 plus 1. And 500 divided by 4 is going to give us 125 plus 1. So we get 126 numbers. Now obviously, if we did something like this, it would take a long time to solve. So we have 2 more problems. At this point, I recommend pausing the video here and attempting it. So I know 34 is not a multiple of 6, but I want to know what's the next number. So I'm going to do 34 divided by 6, and I'm going to get 5.67. Now in this case, I don't do 5 times 6. If I do 5 times 6, I get 30. That's a number less than 34. So in this case, I do 6 times 6 and I get 36. So my starting number is 36. And same idea for 50. I do 50 divided by 6 and I'm going to get 8.33. Now my last number, I actually choose 8. So 8 times 6 is going to give me 48. So my starting number is 36, my last number is 48. And so using the formula, 48 minus 36 divided by our multiple, which is 6, plus 1. 48 minus 36 is going to give us 12. 12 divided by 6 plus 1. 12 divided by 6 is 2. 2 plus 1 is 3. So there's only 3 numbers. Because there's only 3 numbers, we might as well prove it to ourselves. So we get 36. 36 plus 6 is going to give us 42. 42 plus 6 is 48. So we see there's 3 numbers. Last one from 5 to 841. So again, if you do 5 divided by 3 is 1.67. This one might have been obvious. You obviously know it's going to be 6 because 5 doesn't work. So the next number is 6 and we know 6 is a multiple of 3. But here I'm just showing all the steps. So then I take my 2, I multiply it by 3 and I get 6. So 6 is our starting number. Then we do 841. 841, maybe I don't know it, so I'm going to just divide it by 3, and I get 280.33. So then I take 280, and I multiply by 3, and I get 840. And so my last number is going to be 840. So last is 840, The starting is 6 divided by our multiple, which is 3, plus 1. 840 minus 6 is going to give us 834 divided by 3 plus 1. And 834 divided by 3 is going to give us 278. And 278 plus 1 is going to give us 279. And so there's 279 multiples of 3 in this particular interval. And that's all we need to do for this problem.